Jim Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. Welcome to another episode of Global Topic. I'm Jim Kunkel. Today we'll be talking about concrete surface preparation for wastewater infrastructure. And joining me today is Travis Gold, who is a coating consultant with Atlantic Coating Consultants, which is a Tanemi company. I hope you enjoy this interview. Hey, Travis, welcome to Global Topic.
Hey, Jim, thanks for having me on.
Hey, if you could do a favor and take a minute or two and talk a little bit about your background in the industry and also a little bit about Atlantic Consultants as a Tanemi company, what you do for the industry.
Sure. So I've been working as an independent consultant for Tanemi for around 8 years now, and that's how we're structured all over the country. You have small companies that are tasked with representing the larger manufacturer, Tanemi, and we sort of go to market through every available avenue, be it working with engineers to develop specifications, working with owners to do the same, working with contractors to get the job done, and we sort of bring it all together. So we'll work with an engineer from the initial design through the specification, through the bidding process, through the construction process, all the way to the closeout and all the high fives at the end. So we're sort of like a whole picture there. We like to get down and dirty.
So, let me ask you, when it comes to wastewater treatment, how harsh of an environment is it when it impacts, concrete through the stages of wastewater treatment?
Sure. So, interestingly enough, over the years, wastewater treatment has become more corrosive to concrete with the odor control systems, the roofs we've been putting things on. Without a roof, right, a big vat or a gravity thickener just goes out in the air. The neighbors complain, smells a little bit, but it doesn't hurt anything. As soon as you put a roof on that thing, the corrosion that can occur becomes far more severe. There's pictures I could show you, or if anybody wants a presentation, we can look at pictures and we'll see reinforcing steel and rebar just exposed in the whole structure. It can be extremely severe. And then in other situations, you can look at 40-year-old concrete and it just looks like a little rough, but it can be very severe.
So in relation to concrete condition assessment, what are the more important tests that need to be properly assessed, to assess the current condition of concrete in a clarifying structure, for example?
Sure. So there's a number of different phases that we're going to be assessing. So typically, before I even get involved, an engineer or somebody will go out and take a look. Okay, do we see large pieces of concrete missing? Do we see an existing coating, right? Maybe there's an existing coating system on there, which is going to hide a good bit of the actual substrate. So, of course, we want to see, is there big chunks of aggregate showing? Is there any rust bleeding through? That's typically a bad sign. Or does it look kind of like run-of-the-mill concrete that's just old and nasty? But that's all pre-construction. That might even be pre-specification writing. And then there's a whole nother set of things we'll do once the contractor's actually in there. So that sort of speaks to the art of writing a good specification so we can plan for contingencies so that it's not a ka-ching change order machine out there because you bid the job knowing full well you're going to have to do more than what was in the specification, which might be great for the subs, but overall it doesn't help the industry.
So, once a condition assessment is completed and it's determined in order to preserve the concrete clarifier that the structure is in need of surface preparation, repair, and application of protective coatings, what are some of the typical methods to prepare the concrete?
Sure. So traditionally, for many years, we've been abrasive blast cleaning, right? The old-fashioned way. You go down in there. First, you're going to want to clean it because these places can be dirty, about as dirty of a place you've ever been. And then once it's cleaned off, you go in, you blast it, and we're removing any latents on brand new concrete, which is sort of a big hump for folks to get over. You pour brand new, beautiful structures. We're still going to abrasive blast clean, getting all loose everything off, all the existing coatings off. Many contractors now are electing to use either like a wet blast or a high pressure water jet, just because one, you have silica regulations to contend with, and two, the cleanup, shoveling, depending on the structure, shoveling blast media out can be a lot of work. It can be as much work as the whole rest of the job in some instances if you're way down in a hole somewhere. So typically some sort of blasting. You could grind, you could scabble, you could do anything you really want, so long as we get to the desired result, right? So long as we get to the correct profile for the coating system that's going to be going on there.
Yeah, as opposed to overblasting steel, what problems can arise if concrete is overblasted?
Sure. We see things that would look like overblasting in existing structures pretty often. So what we'll have is a structure that's been in service for many years. It actually has quite a bit of corrosion of the concrete, and the paste has become so soft that you go in there and blast, and your aggregate's just falling out, or you end up with this extremely textured surface because the paste is just disappearing. So then you have to resound it, make sure the aggregate is tight. And let's say this goes back to the point about specifications. You might have a 16th inch of a resurfacer specified. Well, if you just exposed 3/8 of an inch or a half inch of aggregate everywhere, that specification it needs help, right? There's going to be a change order. There's going to be there's always a solution there, right? We can fix anything. There's materials we can resurface up to 4 inches. We can do that. It's just going to create an issue. But as opposed to steel, like in steel, we'll see, I was kept blasting the stains off and just going and going, and they never came out. Well, there's a whole host of issues there. In concrete, if it's loose, it's got to come off. So it's sort of overblast. In the steel world, you would call it overblasting, but in concrete, it's more of just the job wasn't done yet, so I kept going, which is it creates a lot of, hey, Travis, can you come out here and take a look at this? We were planning on starting work tomorrow. And then, of course, this resubmittal on all this process. The main problem is time. You lose time.
Yes. Time is money.
Always.
So, once it's determined that the surface preparation of the concrete was within the requirements, typically what types of repairs might be needed, prior to the application of coatings?
Sure. So in the most extreme cases, you'll have exposed rebar, or even if you see rust bleeding out of the concrete, we typically like to chip it back, coat the rebar, and then pack that. Even on a brand new structure, we're still going to repair. Typically, we'd like to see a resurfacer spread about the whole surface because we're blasting, we're opening bug holes, we're opening all these things up. It's very challenging to get a smooth coating film on a surface like vertical concrete that, even despite the best placement methods, you're going to have bug holes. You're going to have these imperfections. We want to smooth it all out so that when you apply your coating, it's pinhole free film. We're looking for homogeneous because what we're doing here is providing a barrier. It's not like steel where we can get galvanic corrosion protection. It's barrier, man. That's what we're going for. So in most cases, or we've almost always recommend that resurface. It doesn't always happen. There's reasons it might not require it, things like that. But that's like the whole field of the surface. The other thing we're going to do is it's a sort of repair. Do we have cracks? Do we have spalling? Do we have joints that need to be addressed? That's sort of a repair, but it's all sort of done at the same time. We want to get it ready, the end result, to be a smooth, beautiful, almost like a big tile with no grout joints, and the resurfacer is trowel applied. We're pushing it in, working it in. You can, it's a pretty neat process.
So prior to the coating application, inspection should be completed. What are some of the important inspection tests that should be conducted after those surfacing and repairs have been done?
Sure. So really, prior to the resurfacing, we're going to want to check things like pH, especially on new concrete. We're typically can assume that the pH is somewhere high, around 12, right? As that concrete gets deteriorated, a lot of those processes will drop the pH. So in addition to creating a weak layer, a weak composition of concrete, that low pH can allow corrosion to occur in the supporting steel and rebar. So we typically try to prepare the surface back to a pH of somewhere around 9 or more, right? That has structural integrity. There are always what if scenarios, but that's a test that really should be performed. And there's I can send you white papers galore about test methods for pH, because there's not one agreed upon in the world test there, because different dilutions and what's the water and what are you getting from the surface. And if we have the correct pH, we're going to look at the surface prep, right? With visual comparators. What concrete surface profile are we looking for? And after that, we're ready to go, ready to resurface. And then just the general visual observation, I call it, right? I'm a consultant, not an inspector, so I observe. I go in and I look and I say hey, how about this termination here? Maybe we should, do a little something different there. So that's not a real test, but it certainly is an important hold point that as an inspector, you're going to want to be present for. As an engineer, you're probably going to want to write in your specification. It's that post-prep walkthrough. What's going on? And that's the time where you can do your pH. If you want to do a pull-off test to test the strength of the concrete, that's a great time for that as well.
Yeah, Travis, what a great conversation we're having. In closing out this episode, is there anything that we didn't talk about that you'd like to leave with the viewers?
Sure. We could talk for many moons about what happens next. We got it prepped. We got it resurfaced. Now, what coatings do we put on there? So I think typically when we're talking with an engineer, they want to learn all about the coatings and the resins and all of that. And I say, look, we got to talk about prep. Here, we just talked about prep, but it's important for everyone to understand that epoxy is not epoxy, right? There are many different levels and grades and formulations. So performance matters with your lining system. And that's what it is, really. It's coatings, but we're creating a lining system. So choosing and specifying the correct materials that are A, user-friendly, so you're actually going to get what you specify, and B, formulated and tested for the specified environment. If you get all of that, we got the prep figured out. Put the right linings on, and then you and I both can retire before it needs to be redone. So, your local Tnemic rep can help you. You should learn to love and trust us, but always verify.
Very good. Yeah, trust but verify. For viewers of the episode, I'm going to make sure that I have contact information and the connection for Travis for his LinkedIn connection, if you do want to connect with him, in the video description for this episode. Travis, thank you so much for the opportunity to talk with you today.
Jim, thank you very much. I look forward to maybe coming on again sometime.
Great. That sounds like fun. Hey, have a great day.
You too. Thanks.
So, Joe, for the lay person who's watching this episode who might only think that corrosion engineering